So 11.2. Again, I like to begin the sections with a little Common Core quote here about the Common Core standards. So in grade 4 Common Core standards, we find students describe, analyze, compare, and classify two-dimensional shapes through building, drawing, analyzing two-dimensional shapes. That's what this is all about here. Students deepen their understanding of properties of two-dimensional objects and the use of them to solve problems involving symmetry. All right, so again, this chapter 11 is laying out all the basics of geometry. We're assuming no geometry knowledge. We're starting from the ground floor, and we're going to get pretty fancy by a couple months from now in what we're doing geometrically. We're going to eventually do proofs. Maybe I should have said that in the first day of class, and you might want to shift it to another instructor. I'll show you everything about it. I don't mean to randomly scare you by that. It'll be good. But I just want to let you know, we're going to big places. By the time we're done, my plan is that you'll know a lot of geometry and be very comfortable with not only the shapes, what they mean, but the logic behind why the things that are true. You'll hear me say a million times, that's what math is about. Right? You're going to have those young folks that are future engineers and architects and scientists sitting in your classrooms, and you're going to want to show them the beauty of math, and the beauty of math is the logic. Like, why is it true? Not just rule. How boring. If that's what math was, just a bunch of dumb rules, I would have never studied math. But it's beautiful truth. This means that has to mean this other thing. So that's where we're going. So we're still in the beginning chapter. I'm not talking about the end there, but we're still in the beginning, laying out the foundations. So two-dimensional shapes and the properties of two-dimensional shapes, which you'll eventually tell others. Let me blow up that picture. There it is, a little bigger. So basically, we're going to go through some classifications. This will be really simple. You're probably not used to it yet, but it'll be simple once we talk it out here in just these few minutes together. Simple, closed, polygon, convex, or concave. So here's the definitions. This will be on YouTube. This is right out of your book. You can get this yourself. When you're on any homework problem, click question help, and you can get to the book. And I'm just taking this out of the book. So a simple curve does not intersect itself. So the first word, simple, just means it doesn't cross itself. So let's look back here. Which of those shapes do cross themselves, are not simple? That one, huh? That's the only one that crosses. Notice he doesn't have a check mark in the simple column. He's not simple. He's more complex. Right? So that's easy. All right. So he's not simple. All the rest of them are simple. They have a check mark in the simple box. All right. How about next? Closed. We know what that means. It's closed. We don't need to read their words. So notice which ones are not closed. This one and this one are open. They're not closed off. Thus, they're missing the check mark in the closed column. All the rest are closed, aren't they? So easy so far. Next one, polygon. Now, what is a polygon right here? Polygon is simple and closed, so it's got to meet those first two conditions. It's got to be simple, can't cross itself. It's got to be closed, can't be open, got to be closed. And only segments as sides. That's kind of a funny way to say that. Let me say it more clear. The sides must be straight, not curved. That's what they're saying. When they say the sides have to be segments, they mean it can't be curved. So a polygon can't have any curved edges. If the shape has curves on it, it isn't a polygon, in other words. So what's a polygon? Poly means many. So polygon, many sides. A polygon has many straight sides. That's what it means. A polygon has a bunch of straight sides. And it's closed, and it's simple. It doesn't cross itself. So let's go back and figure out which ones are polygons. And of course, you can tell because they've got the check marks. Boom and boom. Only this one and this one, among all those, are actually polygons. All the rest are not polygons. Why? Why are they not? Well, this one isn't closed, and that one's not closed. So they don't even have a chance. They got to be closed. This one, why is he not a polygon? He's bendy, right? He's supposed to be straight sides, no curves. He's got a bunch of curves. A circle, obviously, it's all curves. And what's wrong with this guy? Why is he not a polygon? Crosses himself. He's not simple. And what's wrong with this one? Curve again. It's got a curved top, so it's not a polygon. So polygon, straight sides, simple and closed. Next, we're going to talk about concave and convex. I think you feel that right away. You know what concave is, huh? It just means it's caved in. Caved in. Now, they give an official math definition. Instead of just saying it's caved in, because that might seem like, what do you mean? We know what we mean when we say caved in. But the formal math definition is, if you can ever go from one point inside the shape to another point inside the shape, and you travel outside the shape, it must be caved in. That's the formal math definition. If you can ever travel from one point to another, and it takes you outside the shape, it must be caved in. So that's the official definition of concave. So you know which ones are those, right? If we look back to this, which ones are caved in? Well, check mark, check mark, check mark, check mark. Those two, right? They both, this one caves in right here, doesn't he? And this one caves in all over the place. So those are concave. The rest are not. Well, the other two, these are the other two that are convex. It's got to be simple and closed or something like that. Yeah, simple and closed. So it's just among the ones that are simple and closed. Is that good? So just laying out some foundations. Let's go to this. You probably know this, a lot of these anyway. Triangle, 3 sides, quadrilateral 4, pentagon 5, hexagon 6. Then there's higher. I'm not going to put something really tricky and ask you, what's a what is that? I don't know how to say that. I've never even heard of that word. Hendecagon. I'm not going to suddenly throw that on the test and go, how many sides? That'd be weird. So anyway, just know the basic ones. And let's finish with this. What's a regular polygon? Regular polygon. It actually means perfect, yeah. All the sides and all the angles. I just think they picked the wrong word there, but it wasn't up to me. But regular sounds so plain, doesn't it? It's just regular. But in reality, it means perfect. A regular polygon is perfect. So a perfect pentagon or a perfect hexagon, meaning all the sides are identical, all the angles are identical. It's exactly perfect. All the sides, all the angles match up for any number of sides. It's perfect. It's called regular, and we'll talk a lot about it in days to come. It becomes important.